Thanks, Bala. Quick review, and then excited for this hands-on session. Now, I think like all people, whoever can code along with me can do that, but otherwise it would be a lasting, energetic, and code enthusiastic session today. Okay, so before I start with the actual things, maybe let me share the screen first of all. Let me know if you are seeing it.
Yeah, we can see the screen.
Okay, let me zoom in a bit. Okay, so visible, right? Okay, so okay, we'll do a quick recap for just 5 minutes, and then we will slowly come into the advanced architectures. We'll discuss a little bit, and then start literally diving on to the onto the practical session. Okay, so we started with the basic RAG, and we understood the embeddings play a very important role in RAG, like how they get ingested into a vector stores, and then get them back onto the updated query context. We call it as augmentation stage, and then finally pass it to an LLM, and then get the actual answer for a given user query. Then we saw like how many different problems would be there inside a given RAG at every step, starting from your embedding model, chunking strategies, vectorization, indexing, and query ambiguities, and finally the context itself is like off track. And then slowly we talked about different architectures on mitigating these particular problems at every step. What is the solution that can help us as a handy commodity or an entity to solve these particular problems? So we saw different architectures on solving these problems. And finally, we went into one of the problem technique solving, which is chunking strategies, which is very important. And the different chunking strategies that anyone can experiment with for getting or attaining better accuracies. And how that would be done, we have a source document and extracted chunks with different kinds of frameworks that are available. Of course, the top 3 are the frameworks, and the last one is only the chunking library. So yeah, people can actually do that. Of course, there are a couple of pending tasks, and whole last week was busy, so I have to send my material along with the code repository. So I would be pushing all the code for you guys, hand it over to Praveen or Bala, and then they will be circulating in the groups. Okay, I'll do that. And yeah, you can fork from GitHub and okay. That's all from the last session, which is like very quick recap. So now what next? Okay, so these are the high level RAG techniques to solve couple of problems which are like complex in nature. Okay, example, let's take an unstructured document of PDF, and suddenly start asking a question. With the previous techniques like the chunking strategies and all, if you try with n number of permutation and combinations also, there could not be a much bump up inside your accuracy level. So with this, people have seen, okay, even though we are doing a lot of experimentation, like there are some drawbacks that's been happening and seeing over there, and because of which few methodologies has been published as official papers. Okay, so one is hypothetical document embedding. So what does that mean is, you give a query, okay, and the LLM in fact generates hypothetical answers for this particular query. Let's say you ask what is condensation or what is osmosis. Okay, so for this there are hypothetical answers which are not the exact answers, but on hypothetical answers there is a parameter like how many hypothetical documents should be generated. Again, this is one of the hyperparameter which you can tune. So those many numbers, for now let's consider 5. So 5 hypothetical answers are generated, and these generated answers will become your source of, maybe let me turn on my video as well, I'm sorry. Okay, so I just realized it. So so those documents, those answers will become the source documents for us. So those answers or the source document will now get converted into vector embeddings, and that will be searched against your vector database. It's not the original source query that a user has asked, but it is the hypothetical documents that are created will be searched against the vector database. Reason? It will increase the highest level of vector matching, because you already tried to guess some answers, and that answer will start matching the actual chunks that are being ingested into the vector databases. So this will track. I'm sorry.
If I may, one question so that I understand. So does hypothetical document is an intuitive way to understand this? Is it like rephrasing of the user query?
No. Rephrasing is different one. We have a very specific technique which is called query rewriting.
Okay.
Okay, query rewriting is rephrasing your query.
Sure.
Okay, but the hypothetical document embedding is you have a query, but we are not touching that query anymore. So instead touching of the query, we generated our own answer. Let's say osmosis or diffusion. We say, okay, this is a scientific phenomena to attain something. Okay, maybe. Okay, so this is my answer. Now this answer is considered as a source for searching against the vector database, instead of you searching or creating an embedding for what is osmosis or what is diffusion. We embed the answer that is generated and then start searching inside our repository or knowledge base or vector store or anything. Reason for that is already you have an answer. There is a lot higher probability that your matches will have a highest close similarity, and then you get the top k results in a best match manner.
Got it. So this will work better if the term we are searching for is some public knowledge and a lot more internal knowledge, correct?
Yeah, exactly. So
so Pawan, if I understand correctly, the query or maybe the prompt, what you can say that this is the answer I would like to have it something, or you can ask the model itself, the LLM itself, saying that okay, what can be the likeliest answer, and that answer can be fed as a document or something. Is that the way you can go with?
You can. There is an opportunity of going there, but if you do that, we will bias the LLM, because you should not say this is how I need it. The reason being is, now if you say that, you are trying to ground or cut what the general answer would be. Now in that way, it will not be hypothetical. So you already said it, right? So we will not, in a hypothetical phase, we will not even touch the capability of an LLM. So in fact, we leave it to LLM to generate completely hypothetical documents. It's on its own intelligence. And now we will try to get these documents searched inside the vector database, and then we get the top relevant matches, right? That matches will be our context, and that will be sent to an LLM again, fusing with the actual query. Now, how hypothetical documents are out of scope again. Hypothetical documents are just for us to search inside the vector database, get the top match, forget these hypothetical documents, and then take the most relevant documents that got out of the knowledge as your context, fuse your query, which becomes your augmentation, send it to an LLM, and that LLM will give you an answer. So,
Right.
so this is the way exactly how it works, and we will see this in practice. We'll have a literal example on this. Okay. And now context enriched document. What exactly is this? There is always a chance, right? Even though we are doing chunk overlapping, you saw previously we said chunking, chunk overlapping, all these things. So since, okay, keep one point very deterministically inside your mind, that even though we are going into advanced architectures, your previous methodologies or procedures are still there inside coding. By doing all those things, we will start imposing these advanced technologies. So chunking is there, chunk overlap is there, and along with that, we are imposing hybrid. So that means you are increasing the limits and boundaries of RAG now. We are expanding. We are not cutting and then leaving it aside. Okay. And now context enrichment. Okay. So we have already the overlaps and all, which is telling like what is my boundary line, but still there is an overlap between this, such that LLM or the knowledge base knows like what is related versus what is not related. But even though you're not reaching the desired accuracy levels, maybe like your threshold says like I have to reach 90%. Example, mission critical applications need that, like aerospace, medicine, all these things need like 90 to 95% of accuracy. Other things they can compromise, right? So in that way, So even though you are doing chunking and overlapping, that may not suffice the needs. That way, like we got into one more methodology, which is called context enrichment. That you have a context, and then you know the nodes inside your knowledge base. If it is like a graph kind of thing, you know the adjacent nodes of a particular context. If you, let's say, from a knowledge base, you pick the top 5. And for this top 5 nodes, you know the adjacent nodes already. So we'll pick those adjacent nodes and we create that as a context before and context after. And that whole context becomes and fuses with your query, becomes an augmented query. Now you just imagine what you are doing. So we created a hypothetical document, searched for it, got it, the most exact relevancy data, and then fusing it to an LLM. And now here you are creating a boundary of context and fusing all the things to an LLM. So you are making it more understandable to the knowledge that we are retrieving, at the same time the question that you are asking. Okay. And then the fusion retrieval. This fusion retrieval is very interesting. So we do it two ways. I'm not going too much backward in timeline, but there is something called TF-IDF. If people know it, they know it. But otherwise, like, you can ask me questions, then we can take it here. TF-IDF is term frequency and inverse document frequency, which like it's term-wise search. Okay, very similar to what is diffusion. So something flowing from a high density area to a low density area. Okay, diffusion. So so that means, like, so we searched what is diffusion. See, we search for what, we cut off all the unwanted words like this e's and all, which are not playing any much role inside this query, and then we search for diffusion. So all the documents what and then diffusion will come into my picture. But that will actually screw, because there might not be the actual context in the document. Maybe something is explaining the core intricacies of a diffusion, which is not needed. I only need a definition of a diffusion, which may not be there in that particular document. So I'm not giving the right thing to an LLM, right? Now what we do is that we will do anyhow direct term matching, and then we will also do the dense search, dense vector search, very similar to what we are doing in RAG. It could be context window, or it could be hypothetical document, anything. Okay, that would be your dense vector searching. Okay, so now what we do, the results from the best match 25 and the dense vector, we will fuse it as an augmentation and then pass it to an LLM. Now what you did, instead of getting 10 documents, you got now 20 documents, because 10 from BM25 and 10 from dense vector. So you increase a lot much context. Now LLM can exactly infer what exactly you're searching for, because it has got more knowledge to see now. Okay, and then again, now this is an ensemble method. Okay, so you have chunking, you have embedding, you have vector databases, and then you have different LLMs. These all LLMs are from different vendors. Okay, so it's not from the same vendor. Could be from Microsoft 5 series, and then you have a Quen from Alibaba series, and then you have Meta Llama, so Meta, and then finally you give a very giant LLM. Could be your Anthropics or an LLM, OpenAI, GPT 4.1, Claude 3.7 with reasoning, or GPT-4, GPT-O3 Hive with reasoning, or something like that. So now what this LLM is doing, it has got the reasoning capability. So now this LLM has fed with the loop back with the actual context from the vector source and the answers given by all these LLMs. Okay, so now these LLMs, when they actually fuse the answer with an augmentation phase and pass it to the LLM 4, LM4, which is like a reasoning model, could be a reasoning model. This will start thinking whether this answer that is coming from here and the vector database, that is the actual context that I have, whether it is in the right direction or not. Okay, so that will have a loop back, and if at all not, maybe I'll flow it back saying that okay, not, you are not right, and maybe that loop continues until and unless we satisfy. Or if it's still not getting satisfied after a few iterations, we hard stop saying that we are not going into a convergence mode. We call that as a convergence mode. We are not converging, so we'll stop it. Okay, and this is an ensembling method. This is far more better, like 3 different LLMs visualizing and analyzing, and 4th LLM giving a reason whether it is correct or not, and finally you have an answer to that. And now these days, I think you might have heard or seen this term agentic RAG. to a larger extent. RAG is done. Okay, people are using RAG, but now suddenly agents came into picture. People again started running behind something called agentic RAG. What exactly is agentic RAG? Whatever you have seen from the last 5 minutes, right? It's constant. Okay, but now it all will be done on agents. Okay, let me enlarge it a little bit such that you can see it. Okay, now what happens here is you have multiple agents taking decisions. That's it. Instead of you taking it a phase by way in a workflow manner, it is given to an autonomous agent to take a decision. Now this is the flow, how it works. So you have a user query. That user query, just follow my numbers. Okay, so you have a user query and you are given to one agent, which is like a query rewriting agent. So Bala, your question gets answered here. So query rewriting agent is basically it'll transform your queries. Okay, there is a technique in RAG which is called query transforms. Okay, and there are libraries like the frameworks like Llama Index, LangChain, Haystack. They have all got the query transformer classes. Okay, so and then you pass in the number of transformations that you need. Maybe you say 3. They change your query into 3 different formats. Okay, intent is same, but the query is restructured in that way. Okay, and then these 3 queries are embedded and searched inside a vector database simultaneously, and then you get a lot of documents. That's how it is. Okay, so this is the updated query. For now, just imagine one. So you have one updated query, very maybe let's say very enriched way of doing it. And now what it does is it passes that to a decision agent, and decision agent will take a decision whether do I need more details for this query or directly can I answer it. Okay, so let's say if it doesn't need any information, directly it will hit the LLM saying that okay, and passes this query saying that okay, please go ahead and answer, and it will answer. I get a response, and then I'll pass it to one more agent saying that okay, check this particular agent is aligning with the query or not. It will take decision whether it is relevant answer or not. If it is yes, final answer, give it back to the user. It is all the happy path, right? But when the decision agent says okay, you do I need more details, and then I say yes, because you don't have the knowledge. Okay, what if suppose I give a query like I do have a patient of 60 years who is suffering from nausea from last 3 days, and so and so and so. Can you prescribe a medication for her, or please do analyze her patient history and do let me know the summary. Damn sure, like LLM will not have the predefined answer. So that way it will take a decision. Okay, no, I don't have enough answer for this. Let me check for the relevant answer or relevant knowledge. That is where it will start hitting another agent, which is called a retrieving agent. Okay, so retriever agent is in now contact with the actual knowledge base, which is our vector source. So it passes the query, each query, updated query, and now it does all the stuff that we have already discussed. So top K, top documents, similarity searches, and everything, and I get the top documents, and we fuse them with the context in the query. We make it as an augmentation, pass it to an LLM. LLM will give the answer, and again the loop continues. Go back to a validating agent. Now it takes a decision whether it is matching or not matching. If it is matching, final response. If not, back to the step 1. Loop continues. Okay, so so this is what is all about agentic RAG. Agentic RAG is nothing different, but here the decision making capabilities enriched with the help of agents and the capabilities of agents. Of course, agents are out of scope for this discussion. Maybe we'll see it in some other sessions if Praveen and Bala they come to some stage like we need agentic sessions also. That time we'll discuss very deeply into agents, but just think that agents have are something like autonomous agents, autonomous humans in digital world. That's it. Okay. So this is all about agentic RAG. Now I think like you literally got what exactly we are trying to do here. So we have some hybrid methodologies like hypothetical document embedding, which is called hide, context enrichment, enrich windows, fusion RAG or fusion retrievals, ensemble LLMs, and then finally with the agentic RAG, right? So along with the normal RAG methods. Okay, so with this understanding of the base RAG methods and advanced RAG methods, let's start diving into the practical session and see how actually the concepts work in practice. Okay. So before I spin up my IDEs and all, maybe you can shoot out few questions and then yeah, I can take them up.
There are a few already in the
Yeah, yes, please. I know that. Okay. So okay, anyone, one question I can take over now.
I think one is how do we decide which LLMs to use? That's been asked.
Okay. Actually, this is the most common question I keep on hearing. There is no standard. Okay, there is no standard how you choose an LLM. Okay, it's all about experimentation first thing. Okay, and experience first of all. Okay, and then all the big LLMs, giant LLMs, they have got good knowledge, but domain knowledge as specific, I think they have very little, because that's not available in the public net. So it's all purely depend on your experimentation phase. Like you keep on giving the LLM, and then how the generation. See, LLM comes only in the stage of generation. Okay, retrieval and augmentation are in our hand only. So for a RAG, retrieval and augmentation are far important than an LLM, because which is coming at the generation phase of it. Okay, but if you are going for an agentic RAG, yes, definitely LLM plays a major role, because it has to take a decision which tool to call, whether this is having a right context or not. So these decisions should be made in the inside an agentic RAG. Then we can think of an LLM. So the question is more grounded towards what kind of approach that you are going in. If you are going in a normal RAG or an agentic RAG, then only you have to think on what LLM should I use. Okay, I think with that question I'll pause, and then we'll go on to the practical implementation of the naive RAG first, and then we'll go into the advanced RAGs. So I'm creating a project on my desktop. So saying that RAG session. Hold on, it's opening. Okay. Sorry for that. Maybe I may not increase the fonting here. The reason being is I have to scroll left and right if I start increasing the fonts, and it may be a lot of confusion for you. So I kept it at an optional sizes where you can see it for sure. But if not, I'll also give this code bases. As I said, like you can go through and then come come back and ask the questions. That's also fine. Okay. So first of all, we have to create two things. One, the env file, which has our API. I'm sorry. API keys for any LLMs. Okay, and the other one is the requirement text. Or you can even create pyproject.toml file, toml structure. Okay, so in this we are going, as I said, right, we are going literally by Llama Index these seminars, and then I'll be showing one last example on the Agno agentic RAG, how that looks like. Okay, so what are all minimalistic dependencies that you need to have? It's like very easy. Okay, we say Llama Index, we should have LLMs. So LLMs hyphen, and there are a lot of LLMs. You choose what you need. So all these are different LLMs. Okay, so I'll choose OpenAI for now, and then Llama Index hyphen LLMs hyphen Anthropic. Okay, two LLMs I'm taking. Of course, you can use a local LLM also. Oh, okay, maybe what I'll do is I'll prefer local, because it will be easy for you and give a lot of confidence. Okay, index hyphen LLMs hyphen Olama. Okay, Olama is like the platform which will host the LLMs and can be run on a CPU based machines. Okay, so that is Olama. And now what needs in a RAG? We need a vector store and embeddings. Okay, so Llama index hyphen embeddings. Okay, from where these embeddings would come? Again, this would come from Olama or some provider. So I'll take Olama only. Okay, and now Llama index hyphen vector stores, and you have a quadrant here. So quadrant vector store, and what else we need? I think, okay, anything that is needed we can add dynamically, but this is how we made it. Okay, now I'll say now I'm creating a Python file which I call it as NAIV name rag. Okay, and now we have to install these dependencies in our, okay, now if you see I have a VNV created for my this project, so I'm not interfering with all the environments that I have in my machine. So I use UV, and then yep, it should be pretty quick. Okay, done. So please, my suggestion is don't use pip anymore, use UV. It will be very fast and quick to install all the dependencies. Okay, it's indexing, that's what I'm seeing it. Okay, okay, come on. Okay, before that, what I'll show you is, here is my Olama. It's running already. If you see this, quit Olama. Okay, so it's running the llama image on my task head on my Mac. So it's there here. Okay, and so we want to even get the quadrant. So I am getting my Docker. So how you can get the quadrant is basically you need to run I'm sorry, Docker run quadrant /quadrant. So that's the command, okay, that you need to run for spinning up the quadrant inside your local machine. So this is the local machine, my Docker. So I'm stopping one of my unwanted service. Okay. Okay. And then my quadrant config, I'm spinning up to be pretty quick speed. Oh, sorry. Thing happening. Okay. Oh my God. Okay, fine. It's okay. No issues. If I don't have a local also, it's not a big problem. So what we'll do is we'll spin up a cloud instance right away. So, okay. So go to Google and say quadrant. Okay, go here. Okay. Get started here or here. Anything is fine. So, perfect. So just spin up, give your email address. It says enter the code. Maybe I'll take the code from my mail ID and then give it there. So I can continue. And you have a free cloud instance of 1 gigs in size, if I'm not wrong, which is free forever from Quadrant side. So you can just take that, use it for experimentation. I think that's a very good instance which you can use it for all your POCs. Okay, and no charge, no credit card required. Okay, accept all. So so I'm going into my clusters. I think I do have my cluster. Oh, okay. So I don't have a cluster, so maybe I'll say cluster 0 and create a free cluster. So it will take anything on its need. So it's spinning up the cluster for now. Okay, so this is my API key for quadrant. Okay, no issues. After this, I'll delete. So this is the key, copy, and then go here. You say quadrant API key plus this. Okay, and then you have a quadrant URL. Okay, and then okay, so this is the quadrant URL for you. Okay, copy, then close this. These are the two things that are needed for us. Okay, and now cluster UI. So that key which you have taken, right? So you just that's the reason, like you need to copy that and take it and then paste it here. Apply. Okay, not now. Okay, so these are the collections. This is the console where you can actually try a few of the quadrant commands. This is the welcome doc, and you have some tutorials, and they have some predefined data sets which you can load. Okay, and then you have some access tokens for RBAC. Okay, RBAC is like rule-based access control for this database. Okay, in collections you don't have nothing, so we ingest it here and then see. Okay, and now with that, okay, let's start diving into the code. And maybe I'll just copy and paste a few of the things such that like we don't waste enough time. So I have a lot of imports, copying them. Okay, so okay, Anthropic is not there. Okay, yeah, it's not there. Instead of that, I think we have Olama, yeah, LLMs, Olama, we have Olama here, and we didn't install .env. This is what I said, like as and when we will install. Okay, Python .env. Okay, and you say uv install quick. Okay, why do we need this? We need this because to load this environment files into our code base, so we need this. And you see all this simple directory reader reads the directories from which the knowledge has to be searched and seen. And then hide query transformer. So I said, right, query transformations itself is one thing, and hide query transformer is one thing using which like we define the hypothetical documents now. Okay, and then we have a transformation engine, query transformation engine. We have a quadrant vector store and storage context. Like what is storage context is basically it defines the context for your knowledge. So you have a vector store and storage context, and the storage context holds this vector store as a context and then provides the data to your LLM. And then you have some settings, and then you have embeddings, and then you have LLM itself, and then finally the miscellaneous ones like to load these environments and all. So how to see what all things are there in your Olama?
Yes.
Hello, sir. Sir, Vishnu connecting from Motila.
Sorry.
What is the
Sir, I'm Vishnu connecting from Motila.
Go on. I think there is a
Any question or it like?
No, I don't think it's a question. He was talking on phone. I think the.
Oh, okay, fine. So sorry. Okay. So how do you check like what are all things are available in Olama? So one, it is installed. One, it is installed, right? How do you install? Again, go back to the browser and then say olama.com, and you have clear-cut download instructions. If I click on download, so which environment or which OS platform you're targeting for. Okay, so Mac, Linux, Windows, download for Mac or something like that. And how do you run a model? So go to the models and you check all the models: DeepSeek, Llama, Qwen, Gemma, anything. Okay, and based on their your use case and capability. If you need tool calling capability, which is like agentic capability, just click on it. Like you get all the LLMs which are tool capable. If you need vision and tool, only vision and embedding. Okay, only embedding. Okay, so all permutation combination of models, you can search it, and if you go into any one of the model, they clearly give you the command to get this model up and running inside Olama, which is Olama full nomic embedding text. If you just do this, you'll get the embedding model inside your local machine. And this nomic embedding text, right, it surpasses text embedding ALPHA 002, which is OpenAI's second best embedding model. And then the lower grade of current version of model, which is text embedding 3 large and text embedding 3 medium and text embedding 3 small. So it is even comparable to text embedding 3 small. So now why do you spend money on embeddings from OpenAI? Instead, you can put this in local and then use it for your own use cases, right? So with that, what we'll do is now let us start into the code. So I'm sorry. Okay, so now let me bring the data first of all. So I have the data, so I'm just putting it here now. Okay, so what else is there in data? Data has got some RAG PDF and some climatic changes. Okay, so maybe for now what I'll do is, okay, with this RAG PDF, I don't know what exactly there in that RAG PDF. But for now what I'll do is I'll delete this RAG PDF Okay, and then I'll put the understanding climatic changes.pdf. Okay, and now let's start. Okay, so first of all, we would say load.env and find.env. Okay, and now we have settings.llm. So we have to change the global LLM. By default, the global LLM inside of any framework is OpenAI. Okay, so I'll change it to the Olama one, and you have settings dot embedding model. Again, the embedding model is OpenAI embedding model. Okay, so I'm changing that, overriding those to the local ones. And you have settings dot chunk size. So I'll make this chunk size now. Settings dot chunk overlap is another one that we were constructing. And now how would we do the LLM? Olama, and then what else is there? The model. Okay, is equals to, you give some model name to this, and then the host. If you are hosting it in Olama somewhere else, maybe you have to give this host. I think it's base URL. Yeah, base URL. Else, by default, inside the class, they have hard coded that with the local host. Okay, but still I'll do that because it will be handy for us. Suddenly you can come here and then change it. Okay, and how do you check that models now? Again, Olama list. So it will give me all the list of models that are available inside my environment. So I have Llama 3.1 available, nomic embedding text. I have 14 billion parameter running in my machine, and I have Snowflake architect embedding model. So for now, I'll take nomic as, I'm sorry, nomic is embedding model. Okay, maybe I'll also write this since I copied. So we have Olama embedding, and then it has got a model name. Okay, it's not consistent in Olama. For LLM it says model, and embedding it says model name. Okay, and base URL is constant. Okay, so model name we will put it as nomic embed text latest. Okay, and for LLM, okay, it's your choice. Actually, I used to ask the audience like what you want to choose, but now I cannot. So I'm taking my decision. I'm using 2314B. I don't know, it will be a little slow if I load it. Maybe I'll take Llama 3 and 3.1 latest. Okay, sorry. Okay, so the host is localhost HTTP localhost colon double 11434. Okay, that's the URL of API base URL for Olama. Okay, so chunk sizes for now I'm putting 128. No, maybe like 500 and no, 120 is fine. And then maybe I'll put 30 as my overlap. Okay, so these are the base settings that you have to do. Now let's do the document loading. Okay, maybe I'll write one small def method which is called def load documents. Okay, so underscore docs is equal to, how we have to do is maybe simple directory, and then it has got input directory. Input directory is our data, and then there are something called required extensions. If you have n number of different files inside this data directory, like PDFs, text files, Word docs, then you can actually specify what all to pick up. So I say .pdf to pick up because I have two things. Just for your example, I just kept there. Like one, I have a JSON and PDF, so it will not touch JSONs now. It will only put PDF out of it. Okay, and finally dot say load data, and then there is a parameter which is called show progress is equals to true. That means like how much data is being loaded or read. So you have visually indicating that. Okay, and finally we say written underscore docs. Good. So now I say my docs is equals to load docs. Okay, good. So now I have to create the instance that connects to Quadrant. So I'll don't do that. I'll directly copy it from somewhere I have it already. Okay, so I gave a good commentation for you, like you can go ahead and read it. But I have this URL, right? So instead of this, what we will call is OS dot. I'm sorry, OS. I don't think so. We have OS. Yeah, OS dot environ dot net, and then you can say quadrant URL. which comes from PNV file. Okay, and then I have got os.environ.get of QDRANT quadrant API key. Okay, so you get these two things now. So now what we should do is basically create a quadrant vector store. Okay, quadrant vector store, and then the client equals to this client, and the collection name name RAG. Okay, and this is vector store. And now what you have to do is, we have, as I said, right, like you have a vector store, you have to give it to a storage context to create that context. Okay, so you have a storage context dot from defaults, and if you see these defaults, there are n many things. Okay, you have doc stores, you have index stores, you have vector stores, you have image stores, vector store and vector stores. Okay, and then a graph store, you have property graph store, persistence directory, and then file system. So these many things you can use it as a context. Okay, so for now what we are doing, we are using vector store. Okay, and then pass the above vector store instance here. Sorry, there is a spell mistake. Okay, and maybe this even storage context is equals to, and yeah, maybe I can do it something like now vector store index dot from from documents, because we have a documents and we have to ingest these documents into the vector store. So we have from documents, and documents is equals to docs. We pass this docs reference, and we pass the storage context. Yeah, storage context is equals to storage context. That's it. I think we can keep this as index. And then now what we can do is we can write one query is equals to maybe what we should say is what are the factors influencing the climate change. Okay, this is my question. Now what you should do, now you have a vector store index, right? So index dot, you can create a query engine as query engine. So you'll get a query engine. Okay, query engine is equals to, and then you have a query engine dot query. Okay, and you pass your message or query string. So you have a string. Oh, why is that not coming? So they have to give this string or query bundle. Of course, that would be populated. Somehow it's not coming. String or query bundle. Yeah, not coming, but I can pass my query. Okay, yes. So it will give me response is equals to, and I can even pass LLM also to this if I'm not wrong. Not this query engine. Yeah, if you see this query engine has got an LLM, you can override the LLM at this stage also. Okay, so now you have a response passed into it. Now I can say print response. Okay, maybe response.response or response, but this is the construct of your name that. Okay, now I'll just go through iteration by iteration. So you have a okay, so height transformations, we are not building it anyway. Okay, so we have a simple directory to read, and then you have a quadrant store, you have a storage context, settings, Olama, LLM, and then Olama embedding model and all those things. And then let's run and then see how actually it all works now. So hopefully there should not be any error. Okay, some warning. Where is it coming from? Models.py. Not a problem. So if you see this, my document has been read, your cloud is being populated. Now just go to your quadrant and then just refresh. Okay, no collection yet. Okay. Okay. Okay, maybe embeddings are being constructed. Now, if you see this, these are like localhost API embeddings. Okay, let's see. Once these embeddings are done, maybe it will show you something. Okay, good. So yeah, so name RAG collection with 512 different points got collected. Okay, now if you see this, my metadata has been populated. What is the file name? What is the file path? File type? File size? Collection date? Yeah, I'm sorry, creation date, modified date, and I have the chunk context. So this is the actual content of the chunk, and the chunk default vector size is of 768 dimensions. Okay, so the nomic embedding always gives you 768 dimensions. Like that, if you go into an info, this is all the hyperparameters of your vector store. So you can perform tuning, as I said, right? Vector indexing tuning that you need to perform. So these are the parameters that you can tune to make your vector indexing more accurate, efficient, and all those things. Now you have 1,332 points. That much data has been indexed already for you guys. Okay, and ultimately, now there is an answer also. It has searched and it got you answer. So the relationship between human activity, changes in atmospheric composition is complex. All those things, ability. Yeah, it says like absorb and store carbon. Nitrous oxides are also causing greenhouse gases effects. I think yeah, there is some answer, but you need to now check whether this answer is right or wrong. That's the important phase of RAG, which we call it as RAG evaluation. Maybe RAG evaluation itself is a bigger topic we will take up, but in the last call I told you there are few frameworks which are called RAGAs, and then deep evals, and is something else also I forgot, but yeah, these are predominant two different frameworks that you can use it for evaluation purposes. This is the construct of name RAG. Now, how the what do you say, the hybrid methodologies that we discussed, right, look like. Okay.
Hey, Pawan, quick time check. We have 6 minutes.
Yeah, fine. If people are having next 5 more minutes, I think that should be fine. Otherwise, we will be able to complete. Okay. Now, since you understand the base construct of the RAG, the name RAG, right? One small modification that we are doing it here, if you see this one. Okay, these three sentences or these three things, not even these three, these two. Till here, query engine, it's all common. Now we got something called hide query transformation, include original transformation. That means include original query to true, and then query transformer. We pass this query engine, and then the hide transform into this query transformer, and this becomes our hide query engine now. So instead of you querying with the query engine, we query it with the hide query engine. So now hide query engine dot query. What previously we did query engine dot query. We stop it here. But if you include these four statements, it becomes a hide. So now how hide works? It's back on linking back to our theoretical knowledge. Okay, this will construct and then fuse it and all those things that happens, and finally you have an answer. So you have a better answer. So you can actually run this code to check what is the name thing and what is the hide thing. Both answers you can cross check. That is what is hide. And now going to fusion query. Okay, fusion query. Now if you see, constructs are all same. Everything is same. Okay, maybe like I might have written some cleaning methods and all. If you don't write it, is also not is fine. Like I'm just cleaning the text. I'm removing some commas, tabs, next lines, and all those things. But it is all fine. Okay, and now if you see it, like I've created something called BM25 retriever. Okay, and then I created the vector store. If you see, I'm creating the vector store in such a way that if the collection does not exist inside a quadrant, then I'm ingesting it. If the collection already exists, then I'm just pulling the data out of it. Okay, it's like more logical sense, right? How do you create a collection and how do you ingest the data? If you don't put, what happens is it will complain saying that this collection already exists. I'm just avoiding that. Okay, and now you created the vector retriever as a retriever, not as a query engine. Now as a retriever. Why do you need to do that? Because you have to fuse these results together. That's what we call fusion retriever. Okay, now once you have this vector retriever as a retriever, and you have a BM25 retriever, I will pass these two retrievers into something called query fusion retriever. Okay, inside this query fusion retrievers, there is an array collection of retrievers, bunch of retrievers you can give. saying that vector retriever and BM25 retriever, and I assign some weights to that. So how much of weightage that I have to give to this retrieved result such that my LLM can infer on top of that. So I say 60% should be on the dense retriever and 40% on the BM25. That is like best match 25 retriever. Reason for that, BM25 does not gain the contextual information of the retrieved information. So contextual information is much needed for the LLM to understand. So that's the reason dense retriever has got more weightage than compared to the fusion retriever. And now I have the number of queries of 5. That means when you fuse it, maybe you can have 20, but out of the 20, I need only 5. Okay, and there are different retrievers inside the ecosystems, like the distribution based scores. If you draw this scores as a normal distribution, so you have a distribution scoring that you can get out of it, and then you have something called reciprocal rank fusion, RR. Okay, so this is called fusion modes or reciprocal ranking. That is one algorithm. And then we have relative scoring between the chunks, and then you have simple retrieving. So you can use any one of these to check. Again, these are hyperparameters. Okay, you can just change them, check your retriever capabilities, how best you are getting it at the end of your evaluation metrics. So those all you have to stitch together to make your RAG in the best place, or your RAG pipeline as the best place. And then it's again, these are all again common. So you have a query, you have retriever dot retrieve the query, and then I'm just checking the scores. Otherwise you can say retriever dot query and then finally print the response also, but I'm just checking the scores, how they have come to an extent. But I think like now you are understanding all the above things, they are constant. Okay, so they have you are ingesting the doc, you have the quadrant connections, you are loading the data, your quadrant vector store, storage content, everything is constant. So now the only thing that changes according to the concept is, if at all you are in fusion thing, you just have the fusion retriever. If you are in height, you have the height transformer. That's it. Okay, and what else is there? So we have context enhanced thing that we have discussed, right? Yeah. So in this context enhanced retrieval, you have something called node post processor. So once a node is retriever, so you have to put a post processor to it. So we have a class which is called previous next node post processor, to which like you pass the document store. What happens is, here for this particular document store, the previous and next documents are also retrieved and give it to the post processing mechanism of your query engine. So when your query engine start processing it, it have a context of what is before this node and what is after this node, and based on that your query engine is constructed. And again, all the same, all these things are same, like your similarity top K, response mode, how you need it, and all those things. And finally, you can infuse that with your with your query engine, and then your query engine will act with the post processing and finally give you an answer. So now you understood, right, why I took little time and emphasized, literally coded in front of you, the naive RAG. The naive RAG is the foundation thing, and all the hybrid methodologies or the advanced methodologies that we have literally discussed in theory are just the placeholders which you can plug it inside your naive RAG process, and that makes your RAG pipeline more and more better when compared to your naive RAG. Hope that, I think we are just on dot. I think like I completed it, but after this is not end of RAG, but you have many things as re-ranking. Okay, so you can re-rank the retrieved documents based on the similarities, and then you can actually give it back to an LLM or a query engine such that your answers are far better. And then you have to create a gold data set. That is the most trickiest and toughest part everyone will face in the journey of RAG, because once this answer, see, construction of a RAG, you saw it, like how much fast we have did it, maybe in 10 minutes. Of course, we have taken a little time on explanation, but we have constructed the pipeline in 10-15 minutes. That's how easy you can do it. But how do you compute the accuracies of the answer is the biggest challenge. So you have to create a ground data set for that. And you have to compare this answer with the ground data set, and then maybe take some metrics out of it. then you have to tune these hyperparameters. Lot of hyperparameters you have seen already. So all these things finally aggregate and accumulate as a robust and scalable RAG pipeline. Once you are grounding or merging towards an accuracy of 90%, I think that you can call it as your consistent RAG pipeline, which can give you the believable results for any given defined domain problem. I think now we can open up for questions.
Superb. Thanks a lot, Pawan. There's a few questions, right? So one which I also have the same thought is, what is the overall response time for like Agentic RAG or some complex models that you have put? I'll add one more point over there, which I was thinking as an operator. What would be the cost given the number of LLMs you're processing with, etc.? So if you can cover both of these.
Sorry, I just need to drink some water.
Yeah.
Yeah. So good questions too. What is the cost? Now the current implementation, what you have seen, right? That involves zero cost. The reason for that is we have used the embeddings from local, we have used the LLM from local. Nothing going out of your machine. Okay.
Yeah.
But otherwise on. Okay. So otherwise, if you are using some Anthropics or OpenAIs, you definitely need something called observability. Maybe you saw one of the things in my Docker, right? That is the
session. We had one session on Evals, and we covered a little bit of observability over there.
Yeah. Okay. Observability and Evals. Maybe you have it. So, so you have LangFuse, Light LLM, and all these. Aris Phoenix is one more thing. So we have all these different metric tools, which can give you how many tokens are being consumed. Okay. So
Yeah.
those many number of tokens into the pricing cost of the LLM provider. Okay, that would be the actual cost. Of course, the cost is always prescribed or given by the providers for 1 million tokens. So that means you consumed only, let's say 5,732 tokens. Very random number I have taken from my mind. Okay, 5,732 tokens. So that means 5,732 divides by 1 million into the cost will give you the exact costing number for your usage. It will be pretty less.
Sure.
So that's how we compute them.
Makes sense. Cool. So moving, and second is the overall response time.
Okay, overall response time, it depends on what kind of procedure we are taking and where the entire infrastructure is hosted. If it is in-house on-prem data centers, if you have your is having, I think like that would be pretty fast because it's a private network. And if you are hosting in a public network, then don't put the components aside. That means like your RAG pipeline and your vector store should not be divided as apart. Like example, vector store is in US cloud, and then your pipe is there inside a European zone. So there is a network latency comes into picture. So these all things, and at the same time, your quadrant indexing, as I say, right? So it has to search for them as a similarity, right? So if you tune them, that also consists to some of the latencies and bottlenecks. So these are the key players. Coming to Agentic, I think that takes time. Naive things and hybrid things may not take much time. They will be very much near to 1 second, 2 second time gap we can bring it. But Agentic RAG, definitely it will take time. Reason being is there is huge lot of decision taking and then loopbacks happening between the agents. So it will take time. Very similar to your OpenAI thinking models. If you type a query, so your OpenAI says thinking for 30 seconds, thinking more than 1 minute also, I saw that. Okay. So your deep research do for 30 minutes, half an hour it will think and it will formulate the document. So agents, you cannot put a timeline or a threshold on them. Agents will take time, but the compromise is on the accuracy. So you want a good accuracy and you are incorporating the agentic things, time should not be a bound there. But otherwise, time can be less than 3 seconds, which should be the normal use case for any web applications, classic ones.
Okay, okay, makes sense. So I'll ask one last question from this. After that, we'll open it up to the audience. Sabarish asks, how does a validating agent work? Will it also be biased by answers given by another LLM?
Didn't get that
Question. If Sabrish is in the audience, probably he can ask it better.
yeah. Can the question be repeated?
Yeah, hi,
Hi.
Sabush.
Yeah,
Uh,
which time?
yeah, so during Agentic RAG, I saw that we also validate the answers generated by an LLM, right? The final answers. So how does this validating agent work? Because it will also use some kind of an LLM to kind of check, right? So it should also be biased by the already generated answers.
Perfect question. So one sec, let me open up. Okay, so if you see this, the response is given to LLM, right? Right? This agent is aware of the context already. So that means like when you pass this actual response, it's not the actual response, but in fact the raw ones. It's not the one that you have seen in my name RAG. Like you have printed only the response, right? So that is not actually what we give it to the validating agent. In fact, we pass it with the metadata along with the response. That metadata already have your retrieved document. So that way it will take a decision. And once it takes decision, it will give the final answer. So now this response is fed to the user query, not this one. That's the reason the line that is going to the user query is from here, not from here. Hope that clears it.
Okay, so validating agent is something similar to where yes option is taken during decision making agent. Where is it similar to that particular flow?
You mean to say guess? You said the word guess.
So during decision making agent, right?
Yep.
If it wants to get some more information, it goes to the yes flow, goes through that particular context and generates response.
Yes, correct. So there is one concept which is called LLM as judge. Okay. Maybe I didn't. I mean, say there are a lot many things in RAG actually. RAG itself, people say RAG is very simple, like you construct a pipe and it is done, but it's not. RAG is kind of an R&D. Okay. So too many things involved in RAG actually to make it more robust and scalable in productions. Okay. So there is a concept called LLM as judge. That means LLM has got the capability to judge and verify and score the answer based on the context provided. So this validating agent is actually that. So it can see the context, it can validate, it can relate, and it can score how much out of a scale the given answer or the provided answer is aligning with the context and user query, both. That way it will take a decision. If at all satisfied, it will push or it goes into the loop.
Got it. So it's something similar to what we had discussed about Evals.
Yeah, it's kind of an Evals. Correct. In Evals also, LLM as jet is one of the concepts.
Okay.
All right. Cool. Folks, anyone else has any other question before we close?
So, Pawan, one question, basically. I mean,
Yeah.
maybe it's a trivial thing, probably. If we have this so many, like, name drag to the advanced, so many techniques.
Yep.
I mean, it's pretty, sometimes confusing to choose which one to and all. Do you have like some way, like, okay, I have this many techniques, maybe this many advanced techniques, I can choose and I can go with it? Or is there any way that this kind of a whole setup is ready to use kind of a thing, and I can choose as a user which one to go with? Right.
Good question, Venkat. So for that, like the only, I mean, like at least like I can say two things. Like if you are like too much experienced and then you have tried many things, you have that intuition inside your brain. Okay, I think like for this particular use case, I can just go ahead and pick up. Or else like you have the next best thing inside the brain and then you can apply that. But otherwise, the next go-to option would be the research papers. There are something called survey papers. Not the direct research paper, but it's called a survey paper. Okay, so there are something there are papers called RAG technique surveys or something like that. Like they evaluate different RAG techniques and they will put that evaluation metrics or the comparison metric for a given particular domain problem, which RAG technique has best worked for them in their experimentation. So that way we will do a lot of survey. So maybe that would be one of the options where you can take a survey paper and check like what is working out versus what is not working out. and based on that we can take it. Otherwise, like maybe we can spin up 2-3 teams, then let them experiment with 3 parallel streams on 3 different techniques, compare the results, and finally we can take a decision. These are like regular things as a POCs. Before we start a project, maybe we can do a POCs on 3 different techniques and then come to a conclude like which is performing better, and then choose that as your go-to methodology.
Sure. Thanks, Paul.
All right. Super. I think we can close it at that. Pawan, thank you so much. This was quite phenomenal. I think we would also benefit from the, like if you could actually upload the code and share us the GitHub.
Definitely, I'll do that immediately after this call. I'll push and ping you.
Yeah, so we'll share all these material, even the architecture, etc. So we'll share all.
I think someone raised the hand actually.
I don't see it. Who is this?
Okay, maybe no.
Okay, I think it's for people accidentally raised hands instead of. Yeah. Super. So yeah, we'll actually share that material. We'll put this up on YouTube on Monday. And Pawan, especially thank you so much for taking us through all of this over multiple weeks. This is probably the quickest and the best crash course for anybody who wants to get into RAG.
Yeah, maybe it's like a crash course. I know that. Like it's like too much of roller coaster of knowledge. I know.
No, but it is good. But I don't think you'll need. You probably need to cover only these 2 sessions to get started with advanced RAG, in my opinion.
Yeah.
All right. I really appreciate the time you have actually taken. Thank you so much.
Thank you all. Have a nice day and have a great learning sessions ahead. Bye-bye.
Bye. Thanks, everyone. Have a good weekend. Bye.